Okay, guys, what's the best vibration control product in all of audiophilia? Loaded question, right? And anybody that claims to have the answer, that's a huge red flag. But what I wanted to do today is share with you a due diligence that I've been doing on a particular brand, IsoAcoustics, and today includes an interview with the designer and some Q&A back and forth. And what you might find after going through this video, that IsoAcoustics may be the best vibration control product for you. Stay tuned. Okay guys, welcome back to the channel. This is a very special video on multiple fronts. Number one, it's about vibration control, which is what I started my channel on. I would not recommend you going back to my very first videos. They were very primitively done, but they were actually done for just a group of audiophiles that we were sharing in a text group. Yeah, we were using text groups back in the day, and you couldn't share video on text. So I was uploading videos, kind of letting them see what I was doing in a more video-friendly format that I couldn't share in text. And then I just kind of made them with a public in mind, that I was going to make it public. And then the channel just went from there. But it started with do-it-yourself, testing vibration control products, and then making my own do-it-yourself on a budget, what you could do. And spoiler alert, without having to go watch those videos, what I came up with that worked extremely well in my testing, and I was using actual seismic apps to test, was double yellow squash balls in between two vibropods. And so it created a sandwich that did a lot of isolation that worked really good, especially for speakers and, well, subwoofers in particular. Although you needed to have a lot of them, squash balls diminish over time. It's not something that is a polished product, but people that are on a budget want to try some stuff that definitely made a difference in terms of measurable seismic app, before and after, the amount of ringing it would take out. And a lot of this came inspired by a company, Townsend, that Max Townsend, he unfortunately passed away, but he's a brand that I've always been a fan of their products. They've just been very expensive for vibration and isolation control. And another brand in that same ilk, trendsetter, one of the best in the business, is IsoAcoustics. And so what I did recently in Canada at the Toronto Audio Show is I went into their room and I saw that they did an A/B demo where they were actually on the fly with their footers on these speakers, without their footers on the speakers. And it was a very convincing demo. Well, that one in Toronto, I think there was more going on. The speakers, I think, were wired out of phase. That was contributing to too much other things contributing to it. But then I went back. They were very transparent, offered me to come before hours. I went to Capital Audio Fest, and that had the delta that I was expecting from vibration control. Still very clear. If you watch my IsoAcoustic video, you can even hear clear as day in a YouTube video from a cell phone camera on pink noise alone, the difference of when they swapped it. And this time we double checked the phase so that that wasn't part of the equation. So the next step from this, I like to do very thorough due diligence on any products that I recommend or would own myself. And the next step was to do a formal presentation and Q&A with the designer, Dave, who you're going to see in this video. And he's going to walk you through in this video the entire kind of the whole nexus of what goes into the product and even vibration control in general. Why spikes aren't, there's a big misconception out there that spikes drain the vibrations away and they just magically go in one direction and go away quickly. That's a huge red flag, guy. And that's people that don't understand physics, engineering. It's basically elementary school, just intuitive thinking because of the point it's going to go that way. No, there's much more science, testing, and that's one of the things I want to bring up today is that IsoAcoustics, you're going to have a lot of people that are competing under the vibration control mantra, and there's lots of new companies. Everybody's trying to get a piece of the pie because there is some benefit if you can develop a product that works. If you're reducing the vibrations into your floor alone, just your feet not vibrating, I found that with my subs, that's a less aggravation. But then those vibrations not going into, not causing your floor to resonate, your walls to resonate, your other equipment to resonate. A lot of your transducers, a lot of your turntables rely on mechanical vibrations. So you want to get rid of that as much as possible. And so it's a viable tweak, but there's a lot of voodoo, a lot of false understanding of what it really does. And the delta of what it does is often not clear and not justifying the price. So what I appreciate about IsoAcoustics, they present the science. You're going to see this in the, they present measurements. They went to a lab to test it, their own lab, plus the National Research Council in Ottawa. And then also on top of that, they do these demos at the shows. So when you have a company willing to do all these things, whereas others are just saying, hey, trust me, it'll work, in nebulous audiophile jargon, that's a different story. It still may be a decent product, but a company that does it all, to me, you're not going to be able to even be in the conversation of the best unless you do these things. And then on top of that, no vibration control product, you can predict in advance what it's going to do until you get it on the product. Even weight limits, they give general ranges for weight limits and stuff to which products would work best for this weight range. But the best thing to do is work with the actual manufacturer of the equipment and design, like IsoAcoustic is doing, OEM purpose-built designs. And you're going to hear me in the Q&A talk about this a whole lot with Dave, because this is what I think really separates IsoAcoustic from most all the others, is they are working directly with the manufacturer to ensure that their product is synergistic with their whatever product they're being used under. And that gives you a huge advantage in terms of a chance for it making even bigger a difference than what you hear at these shows and these demos. So a company that covers all these bases, and this is what I want to uncover for you guys, my due diligence I'm sharing with you, I think you're going to really appreciate that. On top of that, this video is kind of special to me because it's also indicating a trend that I'm going to be doing in the industry. They're going to be at the Tampa show, and what I'm doing with this, I did the Bart preview. I've got House of Stereo with Joe Parvey and Gershman. I'm going to start doing more and more pre-show stuff to alert you to things like this that are going to be at shows, so that you know when you go to the show, check out these. I've already done some pre-due diligence on these brands. These are the people you might want to check out and test what I hear and what I say. You can test it out for yourself at the show. So stay tuned for a bunch more Zooms and previews before Tampa. I've got a bunch in the hopper. I don't know how I'm going to get this all out to you, but we're going to start with the IsoAcoustics, so enjoy.
Yeah, mainly just wanted to thank you for joining me for this, because it's been a long time coming in terms of, this has kind of been an episodic series in terms of getting to hear your demo, which I give major kudos to in Canada, being able to A/B on the fly the differences. That first demo, I thought it was so different, and I still believe one of those speakers was out of phase. But then when we went to Capital Audio Fest, we got to test, and it was much more what I would expect, but still huge in terms of a delta that people don't normally attribute to vibration control. But when it comes to pieces of equipment that are dependent on creating vibrations for their sound, whether it's a turntable or speaker, these are two areas where vibration control is less voodoo in terms of the naysayers. There is some benefits to isolating. And I know you've got a presentation that kind of walks through your product in more detail. So I wanted to mainly turn it over to you, so you can maybe give people that are starting at point A and just want to know the technology, know your product. And I saw the slides that you have. I think that's going to be a great presentation to give people. And then we can do some Q&A and even preview where you can live A/B test what you're going to talk about. And you can't ask for much more from a company than to present their material and then give you a chance to A/B it at the show. So yeah, maybe just turn it over to you. Maybe just a quick introduction for anybody that hasn't seen you in my prior videos and whatnot.
Yeah, okay. Should I bring up the slides and get started?
Yeah, and what I'll do is I'll give you, do I need to give you, let's see.
You have to, I have to do the share screen thing, right? But you have to
Yeah,
let
so I
me.
need to give you share screen allowed to, in fact, I'm just going to make you, well, let's see. Share multiple, okay. this allows you to share, and then what I'm going to do is put you on full screen. However, I direct it on my side. Like if I put you on full screen on my side, you can still have us both on each side. But however I choose on this side, that's what it'll show up in the final video that's recording. So I'll put you on full screen and it'll show much bigger your screen
Okay.
than being half. So even if you're seeing me in half the screen, that's not what's going to come out in the final video. So let me go ahead and turn you over to you get full screen, and then you should have screen sharing.
You think it's ready there now?
Yeah, can you
Oh,
do screen? Yeah.
here we go. Something's going on. So do I select screen application window? I want screen, right?
Yeah, and then you have to choose your screen.
Yeah.
There you go.
You got it here now?
Yep, I see it.
Excellent. Okay. Okay. Anyway, well, I guess really what I wanted to talk to you and your viewers about was just the interaction between the speakers and audio equipment and that supporting structure. And we'll look at some long-held beliefs and some everyday challenges. And this all comes together to affect clarity, imaging, and that overall, emotional attachment. If I could just go back a little bit there, I worked for 20 years at the Canadian Broadcasting Corporation, and mostly in the design and construction of radio and television studios, but I had a senior role on the development of the Broadcast Center in Toronto, which is the center of the English network. When it was finished, the building was 1.72 million square feet, and it was the largest multimedia facility in the world. And as you can imagine, with all the floating floors and all the high-tech spaces and everything else, the one thing that always amuses people is that this entire building and all the equipment, the people, and the snow on the roof are all carried on 3,000 isolators. And the reason for that is there's trains, streetcars, and subways in the vicinity, and we were trying to mitigate the terrestrial noise coming up into the building. So IsoAcoustics really started after I left the CBC, and it really came about as part of a hobby. And I was just driven by this whole interaction between speakers and the supporting surface. So very quickly, I just threw this in about, are we listening? And really the whole point of this thing is just to say that when we're listening, it's actually an active process. It's not just a passive thing. And a lot of things that we're going to discuss today in terms of imaging and everything else is indeed part of this natural process that we have in our heads that actually position things and give us that the meaning. So if we look at it as a complex cognitive physiological process to establish meaning and purpose to words, sounds, and patterns that we interpret from our three-dimensional perspective as we determine the sources and its locations and validate our understanding and sense of well-being. Many people will have different reactions based on past experiences, specific knowledge and understanding of any given event or matter. And while something may be barely acknowledged by some, it may stimulate an emotional response to others. As we're discussing the reproduction of acoustic events and musical compositions, let's look in detail of this basic interaction that has a profound impact on our listening experiences. So everything we're going to talk about today really has to do with the boundary condition, and that first boundary condition is between the speaker and that supporting surface. And there's three things to always keep in mind. The first one is the one that everybody thinks of, and that is that the speaker may excite the supporting surface. Especially if you're on a wooden floor, people think about the dissonant sounds or the interaction between the speaker and that surface. But the next one is the structure-borne noise. The energy is conducted through the structure, through the supporting floor. Outbound, it may cause anomalies in the listening environment and adjacent spaces, but inbound, it may come from other sources and enter into the speaker and cause issues as well. The third one, though, is most fascinating, and it's the one that people generally don't appreciate or don't think about. and that is vibrations are reflected or bounce off that supporting surface and are conducted back up into the speaker. So it adds that smear to the vocals. You hear that veiled vocal sound. The bass becomes untight. It becomes sloppy in that. But the really interesting one is that any artifacts that come back up into two speakers that are similar, we perceive them to be in the middle. And they cause the sound stage to collapse and become very two-dimensional. So oftentimes we're asked the question, I understand this, you put a speaker on a wooden floor and you could have an interaction with that floor, but I've got concrete. You're not going to excite my concrete floor. You may not excite the concrete floor, but you do have these structure-borne noises that are carried through. And the density of concrete means that these vibrations coming back up off the floor are even more acute in that third example. So people will often ask, does our product work better on a wooden floor, a concrete floor, or what? And it's really designed to work in any of those situations, because the net result is really kind of a result of all these three factors kind of combined. We all have some of each, if you understand what I mean. So we're talking about this mechanical connection. So again, with a closed boundary condition, if you bolted that pipe to the wall and hit it with a hammer, the vibration will go along and hit the wall, and then the inversion would come back again. If you have some form of absorption, you hit it with a hammer, it goes up and it hits that wall surface, it's attenuated, and you get little or less coming back along the pipe once again. So we're not getting that energy being conducted back up into the speaker. So let's talk about a few fundamentals, a few basics, just to kind of set kind of a baseline here. And we'll start with spikes and mechanical footers. So the spikes, a hard mechanical connection often provided by the manufacturer for floor standing speakers. They firmly anchor the speaker to the supporting surface. They add stability on carpet, and they do reduce the contact area. If you looked at a very modest speaker, you might have half a pound per square inch. And if you put it on a spike, depending upon the radius, that may go up to 5,000 pounds per square inch. May change the transfer of energy to and from the supporting surface, but it's still a mechanical connection. It's still going to go back and forth. Question that's often asked, does it drain or pass energy in one direction only? The shape of a spike is very similar to the shape of a diode, or the symbol for a diode, for anyone that knows basic electronics. There's no anode, there's no cathode, there's no p-n junction. So really, there's no one-way door, one-way valve to the whole thing. The energy will be conducted in both directions. Spikes and footers may be designed with different materials, metals, glass, ceramic balls. They may be different shapes, different colors, filled with gel or sand or what have you. But at the end of the day, it's still a mechanical connection. You may be influencing how the energy is interacting with the supporting surface, but energy is still going to conduct in both directions. There's no getting around that. If we look at isolation in its classic sense, there's no mechanical connection. You've got a resilient material, and it mitigates the transfer of energy to and from the supporting surface. But the concerns are, Newton's third law of reciprocal motion. As the cone goes forward, the cabinet's going back. The net result may be something less than the cone going forward. So you may have losses. You've often heard where people say the isolator may be sucking the bass out, and there's a perception that you may have losses throughout the spectrum. A homogeneous material is effective for only a limited frequency range at a given weight, and the enclosure may rock because the motive forces are way above the resilient layer. There's that mechanical advantage that causes a rocking, may cause a rocking, and may cause distortions as a result. Symmetrical homogeneous materials may oscillate in a natural circular direction. You've probably seen that, where things kind of have this funny circular oscillation. If it's a spring-based system, you require some form of dampening. to bring it back to neutral. Excuse me. Materials may be sticky and stain contact surfaces, and materials may collapse and break down over time, but there is no mechanical connection. So let's look at a third approach, and I'll just refer to it as a hybrid design. And that is where you have no hard mechanical connection. You use a resilient material, an elastomer, a polymer with viscoelasticity. It mitigates the transfer of energy to and from the supporting surface. But with a multi-part construction, you can extend the performance across the frequency spectrum for a given defined weight. There's no single path for energy to flow. If you have a suction cup-like connection with the floor, it anchors the system into place, much like you tried to do with the spikes. And it's firmly connected to the speaker enclosure. So you have this very positive connection, top and bottom. The lateral engagement of the internal structure is resistant to lateral displacement. So we don't have the issue with Newton's third law, because we manage it laterally, as well as dealing with that the vertical isolation and compression. Internal isolators are biased to improve focus, and they're resistant to that circular oscillation I was describing. Isolators are made of a stable, non-staining material, and carpet disc may be provided if you've got a deep carpet and challenges with that. The issue is, so you'll have to make sure that you stay within the weight range, because you can only sculpt the weight range to be a certain amount. And in order for the system to work, it has to sit in equilibrium. So weight is an important factor. So let me just describe what we do at the National Research Council in Ottawa. If anybody's not familiar with that, with the NRC, it's actually a campus of technical and scientific facilities. You're mostly dealing with PhDs and scientists there, and it's available to the to Canadian manufacturers in different segments, where you can work through your designs, work through the testing, and so on with these facilities. So we work in the anechoic chamber. That's pretty basic and straightforward. But we do a lot of work also with the variable laser vibrometer. And we've got a test rig that we use. We put the Gaias underneath the test rig. We have spikes on solenoids that when we activate the solenoid, it picks it up off of the Gaia. It's sitting on the spikes. And we maintain a height variance of less than 6 millimeters or a quarter of an inch. So it's less than half a wavelength at 20K. We can also fit it up with bungee cords. And you can see in the image the bungee cords are suspending the platform. And again, we can use any one of those three configurations, and always careful to make sure we maintain the same height from the floor surface. So this chart summarizes the activity in that testing. First of all, across the top, you see the audio spectrum. And typically when you do a run, you would run 3 times. You would expect a variance of maybe 0.3 dB from run to run. We would go between the spikes and then the Gaias, and it all stays within 0.03 dB. So we're very careful that we're not colorizing anything anyway. And if anybody thought that, we were going to smooth out some of the humps and so on, that's not the goal. The goal is strictly to not to colorize and to respect the voicing and everything that the manufacturer's done with the speaker. But the really important stuff is the stuff at the bottom, and that's where we run the same sweep frequencies through the speakers, but we use the laser vibrometer to pick up the energy that's coming back up into the speaker, and we're taking these readings along the baffle of the system. So the purple line is on spikes, the green line is on the Gaias, and the blue line at the bottom is on the bungee cord. You notice that the bungee cord and the spikes are the bungee cord and the guys are very similar in their nature. But the one thing to take note is that when it's on the bungee cord, it sounds terrible. I refer to it as sounding like foam. The content's all there. You can make out what's being played, but it doesn't have an edge. The speaker is just floating in midair, and it's not accurate. It doesn't have a real sharp purpose to it. And again, I'm not really concerned about where these spikes are occurring along the audio spectrum. I'm more interested in the delta. It's the delta between the purple line and the green line that are those artifacts that I was describing to you that cause the smear, the cloudiness, the loss of bass precision, and that are causing the soundstage to collapse. And where a lot of people think isolation really only happens at the bottom end, it certainly is very prominent at the bottom end because that's where the excursion is so long and the energy is so much bigger. But it does in fact happen throughout the whole audio spectrum. There may be some masking happening, but there's still a discernible difference as you go up into the higher frequencies as well. Here's an example that I think will kind of put this into perspective. I think it's something that people can relate to. WSDG, John Sturrock is the founder, and they're architects and acousticians, and they renovated the studio at the Boston Symphony. And they asked us to come to put the guys under the B&W speakers when they were commissioning the room. They had 6 people there from the symphony and 6 people there from WSDG. And we listened to a piece that they were working on. We listened to a James Taylor song just to get a vocal. We put the guys underneath, and anywhere you stood in the room, it just popped out. They heard the difference immediately, what was going on. But what really stood out for them was, as one engineer described it, their phantom image used to be projected against a pane of glass. It was very two-dimensional. He described it as being on a pane of glass. And suddenly it's like somebody's opened the window and it's become three-dimensional. It's got shape. So as you can imagine, they've got on the floor, on the stage, they've got 38 microphones and decatries above the orchestra, and they're very cognizant of the shape. And now when they're mixing, they're actually hearing it in this three-dimensional envelope. And so, every microphone is picking up many instruments. Every instrument is picked up by many microphones. There's timing differences between all of those microphones. Those timing differences relate to depth and relate to shape. And now they're able to use that, and they tell us that they're mixing faster and much more confidence as a result of having the guys and having that three-dimensional shape. So I hope I like that example because it kind of gives meaning. It kind of gives some dimension to that whole idea about depth and the way that when you have those artifacts, things tend to collapse into this mathematical midpoint. And when you can get rid of those artifacts, you're dealing with just the fundamentals and that three-dimensional soundstage that gets created as a result. Michael Romanowski is a 5-time Grammy-winning recording and mastering engineer, and he uses our stuff on the ceiling and underneath the speakers as well. And he's very much into that whole spaciousness, that whole openness, and everything else, that openness and that clarity, and managing those images. If you understand what we've been talking about with relation to the floor, I just thought we would look quickly at a wall situation where you're exciting the wall surface. You've got cavities, you've got supporting structure. The speakers may be at right angles with the wall surface, which has even a more prominent impact on that propagation. The structure boring noise through the wall assemblies, reflections back into the speaker assembly, and then of course the conduction into the adjacent spaces are challenges to deal with as well. So at the end of the day, if you mount speakers directly on the wall, it's like bolting a picture to the wall. But if you can isolate it or attenuate what's going on with those artifacts, it becomes more holographic, it becomes more three-dimensional in its shape. And just to illustrate some of the challenges, if you bolt an assembly to the wall, there's a 1/4-inch plate that might have a speaker attached to it. You could see how you're exciting that structure, the wall cavity, and so on. If you put a piece of neoprene or some other resilient material behind it, you still have the fasteners that are conducting into that wall surface as well. You can use a grommet into that to try to mitigate that, but as you over tighten it, all of a sudden what was resilient becomes less compliant and less effective too. And you can have a system maybe with sleeves and that where there's resilient material inside, where you've got a live section and a dead section. But these are all things that you're trying to do to mitigate that transfer of energy back and forth into the surface. And I really just show this to show how challenging it can be, because the bottom line is you don't want to have that speaker moving. You want to have it fixed in place. You still want the accuracy of the speaker, but you're trying to attenuate the energy going back and forth. I thought you might be interested in seeing this. This is a wall-mounted system. And that block at the bottom is the isolated block. The section around it can be adjusted so it could be rotated and tilted. But now you've got a system where you've got isolation between the speaker and the structure that's holding it to the ceiling. And you still have a means to, you still have accuracy because you're holding the speaker firmly in place. If we look at turntables and audio equipment, you've got internal sources of noise. You got motors, transformers, and things inside. Again, they hit the supporting surface and they're echoed back up. They're reflected, conducted back up into the system. You've got external disturbances that are causing problems. You may have feedback into a cartridge because of a speaker in close proximity or as a result of that structure-borne noise. The result is that you're raising the noise floor. And again, any artifact that is similar across the channels will again collapse the soundstage. This isn't unique to just the boundary condition between a speaker. Anywhere in the channel that you have artifacts causes that collapse and that change. People understand when they hear cloudy sound or they hear sloppy bass, but when it comes to imaging changes, often they're kind of uncertain where that comes from. It seems a little voodoo, like why it suddenly expanded and changed. And I hope this gives some dimension to that. You can have a platform under the turntable or equipment. And again, with isolation to mitigate the transfer, you're engaging with that platform, but then you're using a resilient material or isolators to keep it from hitting that supporting surface below. And in this case, with our Delos product, we use mass, a large butcher block, so that there's even greater stability for tube amps or sensitive turntables. You're familiar with the Gaia. They have different weights. They have different weight capacities. 70-pound speakers, 120 or 220-pound speakers. We always recommend that you leave at least 10% from the weight limit, and that allows for the center of mass may be off a little bit. And in fact, the curve is declining. So the next size is actually growing in effectivity while this one is on its way down. So we always suggest leaving that 10% margin there. The Titans are a larger version, and they go all the way up to 620-pound speakers. The Orias behave very much like the Gaias, but instead of bolting them into the top, in the Gaia, the top isolator is bolted to the housing, and the housing is bolted directly to the speaker. In the Oria, there's a suction cup-like effect on the top isolator, so it engages with the equipment, speaker or turntable, just as the suction cup on the bottom is engaging with the supporting surface. And the chart at the bottom is just showing kind of the curves of the different sizes and how they interact. And you could see why there's kind of that trade-off at around that 10% point, that you don't want to go right up to the edge. Certainly, if you overweight, if you go beyond the capacity, the two isolators inside will begin to touch, and the effectiveness just falls like a stone. So you don't want to go near that limit. And then this finally is the family of our products. The Aperta sub, the Aperta series for bookshelf speakers and so on. The Gaias, the Delos, Zazen. So in summary there, we think of the Gaias in the same way as a modern tire technology contributes to the performance of today's racing cars and performance cars. Our products complement the modern speakers and components. And we're working with about 80 manufacturers now to at the OEM level. And people like PSB will just use the Gaia straight up. I think we changed the color, the finish on it. Perlissa, we made a completely different housing. Martin is a completely different housing. Sonus Faber, we built a system that is installed into the cabinet and it bolts to the base plate. Instead of being between the base plate and the floor, it's between the base plate and the cabinet. So these are different applications and different products that we've developed in partnership with these different people. And it's growing, and it kind of answers the question, if your stuff is so good, why aren't manufacturers using it? And I think I'd like to think that that's answering that question.
Yeah.
So that's what I had for you today there, Jason. Jason?
Yeah. So maybe keep the slides up. I'll make us a little bigger here and put this so people can see me. I was very intrigued by this presentation because it does walk through some of the common misconceptions to start with. So many people have this misconception that spikes drain the vibrations out of the equipment. And I think you can see from a very, elementary level how people that don't understand physics and science can kind of think that, but it goes up just as much as it goes down. Now, they may change the resonant frequency of what's on it, because as you showed with that, it comes back wave a little bit different potentially, but the ringing and all the things that you're trying to get rid of, it's really not the most efficient way to do any of that. But it does have aesthetics. And then if you're wanting a firm connection through deep carpeting, that could make the speaker more stable in some respects. But for true vibration control, like you guys do, you have your disc and your product, but then you have little spikes at the bottom that can go deeper to get a little more firm into the carpeting. But spikes look good, but let's go ahead and make sure people understand that that is not a science-based or even audible-based thing, unless it's changing the resonant frequency to something you like, but that's such a minefield. It's usually people that just really don't understand yet. So that was really good about the initial part of your. Could you go back to the slide with the measurements?
Yeah, one of our biggest challenges, kind of what you're referring to, is that people have preconceived notions about isolation and about spikes and everything. And boy, they'll tell you what's going to happen before they've even heard it.
There's a big charade out there of people that think they know it all, but really don't. But in any case, and that's why these measurements are so important. You're actually doing it this is the National Research Council.
Well, we do this ourselves in our own facility as well, but we do go to the NRC from time to time, and we did go there in the early days to validate it. And my biggest concern actually was I wanted to make sure we weren't colorizing, and we weren't either. There wasn't some huge trade-off that was adversely affecting something else, So we've always looked at the the coloration, the output as being kind of a baseline.
Okay.
And it really doesn't tell us how we're improving things. It just tells us when things are going off. And we think that's very, very important so that people can rely on that and don't feel there's losses or there's some kind of coloration or skew to it all.
Yeah, so this graph, was this with just one particular brand of speakers, or?
This one is one speaker, that's right. It's a speaker that we used as a control speaker.
Okay.
It had a very flat output to it, but we do it with many speakers. It's not, this is just one that we use because I think it helps to illustrate the picture
Right.
clearly, because it's kind of what you would anticipate seeing in a perfect world.
Yeah, and I think the other question I had, well, it's still kind of shocking to me that on any speaker there isn't more of a frequency response deviation with the different, because in my testing, I've tried different pucks, kind of similar to your design, an elastomer type sorbethane, then very firm structure, and then another level so that whether it's coming down or up, you have a dead side and an active side to kind of get both ways taken care of. But I was actually able to measure some difference in a specific point just doing a frequency sweep. I could hear what you had brought out was the different types of resonances, the ones that are caused by the supporting structure, like the cabinet. So many cabinets of speakers are not made because of budget constraints. They can't be made with CNC aluminum, that is inert. And even that's still not 100% inert. But most MDF based cabinets have some resonance that, especially if it's not that thick, that you can hear.
Mhm.
And what I was finding is that in my testing, it could actually get rid of some of that resonance when you play a frequency sweep. Certainly, you have to play it at a certain level. So this was a test done with a particular speaker at 90 dB. That looks like it was a very well designed speaker. If that's the kind of results it's getting, this was a very well designed. I think the point is, maybe you can correct me if I'm wrong. If you had a more budget speaker with a more budget cabinet, there could be even a bigger delta in what the improvement could be. Is that a fair assessment?
Um, well, if we, I'll break that down into two parts. If you look at the audio spectrum itself, it's just whatever the speaker's doing. We're just following that. So you're not going to see a discernible difference on that part. When you look at what's happening down below with the laser vibrometer, to me, that's very much the signature of the speaker itself. It's the volumetric dimensions, it's the bracing, it's the construction, it's the materials. And I frankly am not that interested in what caused those spikes at any given location. I'm more focused on the deltas that happen. And we have some speakers that are even that show a lot more distortion all over the place. And again, you'll see the attenuation down when we use our stuff. But I mean, that's a whole other science to deal with, trying to deal with these reflections and deal with the issues that are going on inside the speaker enclosure itself.
Yeah, I mean, I guess from your perspective, you should be agnostic to whatever is causing it. But I'm thinking for people that have a much more budget oriented cabinet design, they may be experiencing more of those vibrometer issues than a more sophisticated built chassis. And so even though you're agnostic where it's coming from, people that want a chance to upgrade their speakers as if the cabinet was a little bit better designed, they may get some performance benefits by this upgrade versus having to buy a whole new chassis, a whole new, very well designed structure for that one aspect of vibrations. Now, of course, there's other sources, like you said, airborne, floorborne, there's so many.
Yeah.
And I think one of the things that I've always kind of recommended to people, and maybe you're the expert to kind of give a perspective of whether this makes sense or not, is that I almost think that your subwoofer and taking the subwoofer vibrations would be my highest priority first, and then my speakers, and then well, turntable obviously is very important if you have one. But in my testing as well, I found that the subwoofer sends a lot of vibrations into the floor, and
Oh,
they
yeah.
often don't spend as much money as the floor standing speakers in whatever the footing that they've got stock. And so they just let that go into the floor. And in some cases, I have a video, maybe I'll even put it up if I still can find it. I have a rel sub on a wood floor moving, literally
Oh,
just
yeah.
dancing on the floor with those sleds. And I'm
Yeah.
like, you know, that's a whole nother problem. If your
Oh,
speaker is actually moving with the excursion, you're not getting the output that you paid for by a
yeah.
large, degree. But I've literally seen that happen. And so two aspects is the decoupling is very important, but also the firmness of that structure so that you don't lose the amplitude. And like you said, you just put your speakers on bungees, that's not going to sound good either,
Yeah.
So it's that combination of sandwich and doing it for the right weight. The only thing that I wanted to ask you about is your design is, do you have different in the science of it in terms of the height and the diameter, the cross section? Have you found that be very critical, both of those aspects?
Well, yeah, the whole thing. I mean, when we're dealing with manufacturers, sometimes they have requirements when they want a different profile or something. We can do it in different profiles,
Okay.
but everything we do, it's all really based on the shape. Excuse me. It's all based on the shape, the thickness, and the durometer of
Okay.
the isolators themselves. And I learned a long time ago that you can actually tune an isolator by playing with its shape and by managing that shape. And that's where, we've got two isolators and we've got an insert inside. We're dealing with the reactance between them. Even things like the concave gives us a progressive rate of change on when you're on that on the isolator itself. So those are the things we play with. And so we try to make them in a size that works physically and aesthetically with the speaker, with the application. And many times we do go with a much lower profile. What we're doing with the for equipment now, we've got an OEM series that we're bringing out, and it's a very low profile. So it's a much flatter looking piece because you don't want your amplifier looking like it's up on building blocks or stilts or something.
Yeah,
You want to
this is
keep
one of
it
the things
low
I've
and
found
solid.
is that, yeah, if you raise it too high, then, well, you can change the tweeter, the axis, but
Yeah.
also if you raise it too high, then you also may change the center of gravity. And some of these speakers have a very high center of gravity.
Oh,
So yours isn't that high, but
yeah.
spikes is another thing. These big spikes that raise it so high, you're
Mhm.
actually making it more susceptible to floorborne, airborne. You're changing the center of gravity of it. So what I'm very impressed with is that there is no one answer for everything per se, because the speaker designer themselves knows the center of gravity, or at least they hope. The fact that you're working as an OEM supplier and
Mhm.
not just doing like a lot of other companies do, sell aftermarket and say, oh, mine is the best, it'll work with every speaker the same. I like that you're actually working with the designers and they're doing exactly what you're talking about. Some of them, they want a low profile because they know I don't want to raise the tweeter. I don't want the center of gravity. And this is exactly the variables that differentiate the primitive people recommending this kind of stuff, the primitive products, and the more advanced products that are
Mhm.
actually truly high end, the ones that are taking in all of these variables into consideration. And that's what I'm saying. You've got the measurements, you've got the technology, you've got the science behind it. You're working with the manufacturers to develop ones that are truly synergistic with them.
Mhm.
And overall, and then on top of that, you bring your products to a show where you can AB them on the fly. So you cover all the bases that, unfortunately, in this industry, um, people have had to rely on reviews for that kind of stuff, but the sources of these reviews are always questionable. You're giving the customer a chance to review it themselves. And like I said, you're doing all the things that I've found very good with other products that I've been very impressed with as well. And unfortunately, there's not too many out there that cover all these bases like you're doing. So kudos to you on this and this presentation. If you could scroll ahead real quick, I might have had one other question.
Well, thank you for your comments there. We work very hard on that. And we also think the customer service and stuff is very important. I mentioned to you earlier, we're doing the distribution ourselves. A big part of that is being able to ask questions about stud sizes and application and so on, and just helping the user get have a good experience with it, you know.
Yeah, and probably I just kept talking because it ran into more tangents, but I think from your body language, you were saying that the subwoofer would be something you would recommend as well, being one of the priorities.
Oh yeah,
Okay.
absolutely. It certainly adds a lot of mud to the room, and it's a challenge in that way. And we have seen it where subwoofers are walking around the floor and our suction cup like effect will
Stops that, yeah.
will lock it into place and hold it there. That's just a function of trying to manage that energy laterally in that. I must say though that it's the full range speakers that really give you the real excitement because it's there's so much more content there, right?
Right.
And there's so much more definition, there's so much
That's
more
true.
energy, and there's so much more experience out of that. One story that we often get that always makes me smile, somebody will buy the guys, we'll see them at a show, and they'll say, well, I bought the guys, I put them underneath my speaker. Instantly, I heard the difference. Well, he knows his room, he knows his speakers, and he didn't need two sets of speakers, and he heard the difference. But then he'll go on and say, you know something? My wife doesn't listen to what I'm doing. She doesn't really follow what I'm doing. But the day that I put them on, she walked in the room and said, what have you done? Something's different. And we intuitively know that spaciousness. We know that, when somebody walks outside, it becomes very open and air. And when you walk into the bathroom, it's so reverberant and close. We're very aware of those things. It becomes part of our locating sense. It becomes part of our sense of safety and well-being too. And when you can, it's very satisfying when you can, you get that feedback from people that they're getting that intuitively and recognizing the changes that are happening and are very pleased with that.
Yeah, so I'm glad you answered that way, and it probably will make me revise my guidance in the future in terms of, for the biggest delta in terms of truly helping vibrations, the subwoofer would be priority. But in terms of noticing a difference, because you're full range, I think your bang for the buck on what you would notice is probably on your floor standing. I think the real solution is to address comprehensively.
Yes.
If you were doing one without the other, you may not be getting the highest potential performance. Subs just put so much into the floor. I
Yeah.
know I just don't like my foot vibrating in some of these,
Yeah.
and just that less aggravation of the floor being vibrated in some of these rooms with suspended floor ceiling. I just don't like that,
Yeah.
That's just an aggravation on a mechanical, a physical level. But yeah, the audibility is a good point that you made there for the
Well, and the other thing is just from an experience standpoint, given that the vibrations travel so much faster through dense materials, you could be sitting in your room and the information's hitting your body and you're feeling that information before it's acoustically coming through the air.
Mhm.
And
true.
it's subtle, but it does change the experience. And if you can mitigate that so that you don't have the structure buoyant transmission to your space, the experience is more acoustic, it's more natural, it's more genuine.
Yeah, people don't realize that and it's good that you're doing this for on-wall. A lot of people forget about that. That's another kudos to you. How many vibration control companies are doing anything for on-wall speakers?
Yeah.
That's another level of true high-end, a company truly thinking of all the variables. So when you want to spend your money in this realm, these are the kind of things that separate companies in my mind. But yeah, the other thing that people don't realize is those vibrations going onto that surface, it creates a musical instrument. And basically your walls will sing along to the music. And that's
Yeah.
what the vibrometer picks up in terms of your cabinet is singing along to the music. And you
Yeah.
don't want that. You can hear that. It's very audible, even sometimes with the frequency sweep, but it's a very annoying when you're playing music and you get that resonance. And that easily makes people invest a lot of money into these very expensive cabinet speakers that address that. But still, floorboard, other things still can happen. And that's a very costly way to deal with it. For people that are on more reasonable budgets, this may be a great way to start experimenting. Subwoofers first, floor standards, whichever one you can swing first, try it. But ideally, if you could build up the budget for both, and if you have both, I think that would be the first way to go. In terms of turntables and stuff like that, are you working OEM on that too, or is that something mainly? Okay.
Yeah, we have some manufacturers that we're working with,
Okay.
and we've got some new things that are coming down the pipe too,
Okay.
in that area as well. Yeah.
Well, I'm very excited to see you said you're going to have a lower profile one. Is that going to be for third party?
It's the piece that I'm referring to. There's 3 in the series, and it's OEM.
Okay.
It's for manufacturers
For certain manufacturers. Okay.
to build into their product. We're talking about making it a retail product.
Mhm.
I find that people are not too quick to make changes like that, to screw something in and screw something out.
Mhm.
You know, it's a little bit like asking somebody to put inserts into their speakers so that you can use Gaias, right?
Right.
It's a little bit like putting some kind of recessed puck into your desk. Asking somebody to whole saw their desk is kind of a dangerous proposition.
Mhm. No,
But
yeah.
we're looking at doing that as well
No, I like
with
the
the
OEM
profile.
route because, yeah, this should be part of the consideration working with the manufacturer. As good as your products are for the third party, uh, if the manufacturer knows, okay, I want it a little more low profile. I don't want to change the height of the tweeter. Um, I want a bigger cross section. Things like this are really much more important to me. So companies that are doing that, I know you guys made some custom footers, well, at least the adapters so they fit on my potpourris, and I think they're going to start offering that as well, part of that, because it works so well. I'll do a video in the future on that. I'm just now getting my videos out. I'm so far behind, and we've been having this on the agenda for a while, but I'm glad we got a chance to talk and at least get some of the science behind it and highlight some of the things where I've been impressed with you separating yourself on the other levels. For still some people, they won't believe, they won't care, and that's totally fine. And some people's speakers may not need it. That's fine too. But in my experience, you do not want resonances going into your floor, whether
Yeah,
it's from your
completely.
sub or your speaker. And anything that can help diminish that, spikes will not. That will just send
Yeah.
it right in and right back up. So there's lots of good products out there, but you guys are separating yourselves on several metrics. And that's what I mainly wanted to highlight in this video. And you did a great job with the presentation. So
Thank you.
thank you for that, and look forward to seeing you guys. I know you're not going to be in Tampa, but the rest of your team is. And I would encourage everybody to go do the AB demo, because that's what initiated a lot of this, precipitated all of this discussion we've had today. So thanks again.
All right. Well, thank you. No, we've enjoyed meeting with you, and very impressed with what you've been doing and the story you've been telling. That's great. Thank you very much.
Well, thank you for great product and spending time today. Again, if anybody has questions, go ahead and leave them in the comments of this video. And, Dave can watch the comments and respond as well. But obviously you can reach out to them directly. Let me get that. I'm not a dealer for IsoAcoustics. I'm not getting paid for any of this. It's just strictly my due diligence in something I saw organically in a room in Canada and then in Capital Audio Fest. So there's no incentive for me. Don't call me about ordering any. Although if you are getting the potpourris, we have the adapters already made, and that's something that the potpourri guys will take care of, and Mike Sweck. But I have no affiliation or anything here. But, who knows when I finally get my Airbnb. This is the type of stuff I'm worrying about right now in constructing my Airbnb that's going to be for audiophiles, is that I do not want the walls singing along. I want to hear the gear. I don't want to hear my room. So this is all part of the equation, and you guys are doing it at a pretty economical level that allows people to try it. So again, thanks for that. Look forward to seeing you and maybe in a future show. Do you have the plans to go to any future show?
I guess Montreal is probably the next one for
In
me.
March? Okay. I think I'm going to go to that. Or is it the same weekend as the Southwest Audio Fest?
Sorry, as the
Southwest Audio Fest? I heard some potential that
if I'm not mistaken, I think the dates were split, were moved. They're a week apart now.
Okay, good. So I can go to
I'm
both.
I don't deal with the show schedule directly, but
Okay.
I do think I heard that.
That would be great because I love both shows. So I'm going to definitely try to attend. So we'll look forward to seeing you there. Again, feel free to comment on the video, and I hope to get this out very soon for you guys.
Good. Well, thank you, Jason.
All right. Well, have a great afternoon. Thanks again.
Thank you very much.
Okay,
My pleasure.
bye-bye.
Have a good evening. Bye-bye.